Hi, Mr. Gilbert here. Today we're going to be focusing on hot spots. Hot spots are not at a plate boundary. I know you've been filling out this form. Notice we had divergent plate boundaries, convergent, the three types, and transform. You will not fill out hot spots because they're not a plate boundary. So what are they? Well, they're isolated hot areas. They're freaks where the asthenosphere leaks through the crust. It does not create convection in the asthenosphere. They're not at a plate boundary. They're isolated little hot spots or freaks. Okay, you can see the history of this hot spot because it stays in the same place as it burns through the crust. You'll see an example in class. What does it make? It makes things that require heat. Volcanoes can be made there. Hot springs, hot mud springs, geysers, etc. What do hot spots destroy? Well, they melt rock, depending on what you make here. But basically, it makes features. It doesn't actually totally destroy crust or wipe out plates. It will destroy some crust as it melts. The two most common areas in the world that we talk about are Hawaii and Yellowstone. So here's what's going on in Hawaii. This is the hot spot. The magma's coming up, creating an island. Over time, the plate is going to move to the left. Ta-da! Moves to the left. So here's the island. It was there. This is like, let's say, 10,000 years later. And a new island's created. The old island will never volcanically erupt. The new island's erupting. Another 10,000 years, let's say, goes by. The first island, the second island, a new third island. The old islands are not going to erupt, etc., etc., etc. And this is how the Hawaiian island chain. This is the current island of Hawaii. And these are all the islands. And each island, as you go further towards the west, is older and older and older. And that's proved right here. The hotspot currently is over here. The new island of Hawaii is 0.2 to 0.7 million years old. Look, we got over 1 million years, 2 million years, 4.5 to 5 million years old. This area, 4.5 to 5 million years ago, used to be over the hotspot. The hotspot didn't move, the plate moved. Here's another check out of it. The hotspot right now, the next Hawaiian island is forming, Lohi, and our current one. So you can see there's the new one. Underwater, it's forming. Hawaii is still somewhat active because some of the magma drips up there, but Maui, Oahu, Kauai, Molokai, nope, no chance. Here's a bunch of different hot spots and on Earth. Okay, I mean, there's Hawaii hotspot, all the dots, just so you can see, and any dot is also an active volcano. Moving right on, here we got hotspots of today, like the Yellowstone hotspot, the Hawaii hotspot, hotspots in the Pacific, some are even on continents, etc. And you can see marked on this map as well. Here's kind of the trail of the Yellowstone hotspot. Currently, it's located right under here. So 0.6 million years ago, it made this volcano. 10 million years ago, this volcano. 11 million years ago, 14 million years ago. Remember, was it the hotspot that moved or the plate that moved? It's the plate that moved over the hotspot. You are correct. And once again, here's kind of showing how plates are moving, the arrows, so we can track plate movement because hot spots stay in the same spot and the plate moves over them. I hope you enjoyed your hotspot video and good luck. Have a great day.